Right, so this is a pressure question, but really the difficulty is in changing the units. Specifically, the issue was that the units are awkward. So it's not like changing meters into centimeters or centimeters into meters, but it's like pounds into kilograms. And on top of that, we've got this bit here is going to catch you out. So we've got we've got a starting value of 34 pounds per square inch, which I've just learned that's what PSI stands for. I didn't realize. So 34 PSI, pounds per square inch. Um, anyway, and we're trying to convert it into the grams per centimeter squared, which is actually a weird unit as well. It should really be newtons per centimeter squared or even newtons per meter squared, but grams per centimeter squared. Um, so if we've got that, so 34 pounds per square inch, that means 34 pounds in every square inch. It tells us how many centimeters are in 1 inch, but be careful because this is not how many centimeters squared in 1 inch squared. It's not the same number. The reason for that is we can see from this diagram down here. Imagine we have a little square, which is 1 square inch. That would have to be 1 inch multiplied by 1 inch. That would be what a square inch is. But if we do those dimensions in centimeters instead, it's going to be 2.54 multiplied by 2.54, which actually gives us 6.4516 centimeters squared. So in other words, we can say that although it's true that 1 inch is equal to 2.54 centimeters, 1 inch squared is equal to that many centimeters squared. Okay, so it's this number that we're interested in when we're trying to convert our units for pressure in this case. So what we'll start off with then is 34 psi is equal to, well, let's convert it. If it's that many pounds per square inch, how many kilograms per square inch will it be? Well, each pound is 0.4536 kilograms. So to turn it into kilograms per square inch, I'd multiply it by the 0.4536. So 34 times 0.4536. I've already done all this. It's already written down here more roughly, but I'll go through it again. 4536, and this is going to give you the kilograms per inch squared. Okay, so putting that into our calculator, 34 times 0.4536, and that gives us 15.422. We can see here. There first. In fact, well, let's just look at what we've done here now. So that's how I got to that bit there. Then we've got to look carefully because there are all sorts of catches in this question. We've got kilograms here, but actually we want grams per centimeter squared. So the next stage is to convert it into grams per inch squared. We still haven't done anything with the inch squared yet. So is this many grams per inch squared? Because if it's that many kilograms, it's going to be 1,000 times as many grams per inch squared. So finally, to convert it into grams per centimeter squared, well, if we've got this is how I phrased it here. If we've got this many grams, this many grams per inch squared, that would be this many grams per that many centimeters squared. Okay, and we're trying to ask how many grams in 1 centimeter squared. So it's difficult to sometimes work out here. We might have an idea we're going to either times or divide by this number here, 6.4516. So we want to ask ourselves a couple of questions. Are we going to expect a larger number at the end or a smaller number? If it's this many grams in 6.4516 centimeters squared, are we going to expect more grams in a centimeter squared or less grams in a centimeter squared? So you may realize that you're going to expect less because this is a larger area than 1 centimeter squared. So you're going to have more grams spread over a larger area. And so we've got a smaller area, we're going to have less grams because that's the pressure is saying there's that many in every this many, say, so this would have to be shared across that many centimeters squared. Another way, if you can't quite visualize it, is to redesign a similar problem that's with easier numbers to try to work out what you need to do. So we did that as well. So let's say that we've got a similar problem like this. I'm just going to just move this around again. I said, imagine we had 3 grams in 6 centimeters squared. How many grams in 1 centimeter squared? We were able to see that it's 0.5 grams per centimeter squared, because by putting these 6, this represents the 6 centimeters squared, and these are the 3 grams, then we can say, well, if that's how many grams in all of this, if we started to share it out, we can see we're going to have 1 gram in every 2 centimeters squared, so therefore 0.5 grams in every 1 centimeter squared. So what did I do to get all that? I did 3 divided by centimeters squared. I did the grams divided by the area. And we do the same thing here. We do the grams over the area. Another way to see it, third way, is to actually look at the units. Grams per, this line just means divide. So you're going to do the mass divided by the area. So anyway, no matter which method you use, you can always try a couple of methods until you feel confident. Oh, it is divide. That makes sense. It is divide. And then you just put it through. And yeah, 15 point divided by all of that, and we got it would have been this number here then. Okay, so yeah, so this was a really difficult question. As I said, it wasn't really, I mean, it was about pressure, but the difficulty was really all about converting units there. Okay.